Hello and welcome to this video in which we revise the important reactions of alkenes. You can pause this video and can check the answers. I am solving it one by one. The first is the dehydration, acid catalyzed dehydration. So what happens? So H plus attacks over here. It goes out in the form of water, creating a carbocation formation like this, which is the ideal case for ring expansion. So ring is expanded, and then we have a dehydration, the loss of hydrogen, the beta hydrogen, and formation of cyclohexene. So this is the answer. Second, we talk about alcoholic KOH, and the question says mention all the products. So yes, when we talk about such questions, so there would be two type of products. It's a E2 reaction because the base is strong. So in this case, when it is said that mention all of them, so we mention Hoffman as well as Seitzef. So when we talk about say Seitzef, we have the variants of this because this can show geometrical isomerism. So answer is 2 for this case. When they say Hoffman, Hoffman will have the elimination from the less crowded carbon, and we have only one possibility. So total possibility is 3. The cis trans of this and 1 over here. Next is NaNH2. NaNH2 is a strong dehydrohalogenating agent, so strong that it can cause a molecule to undergo dehydrohalogenation twice. So in this case, we end up getting, after loss of 2HCl, we end up getting a triple bond in the main carbon chain. So answer is a alkyne. Next, these are the two examples of partial hydrogenation of alkynes. First is the Birch reduction, in which we get the trans isomer as the major product. So in this case, we will get the trans isomer. And the second is the Lindlar's catalyst. In this case, we get the cis isomer. Next is the oxidation of alkene in presence of strong oxidizing agent, let's say K2Cr2O7 in acidic medium. So the molecule would break wherever the double bond is. So it breaks from here, here, and here. So if it is breaking 3 times, we have 4 fractions. The extreme left will convert into ketone. The second one will be oxidized on both the sides, so we'll have COH and COH formation. Also the third one, also we have the same thing. It will be oxidized from this side and this side, so we have 2 molecules of oxalic acid, and the terminal double bond result in the CO2 molecule which escapes. Next is the ozonoid reaction. A molecule is formation of a ozonoid, so it will be a ozonoid formation, and then zinc H2O, it will break into 2 halves because the molecule is identical, so we get 2 molecules of acetaldehyde CH3CHO. Next, bromine CCl4, this is example of an anti-addition, and we know for a cis substrate, if you have a cis substrate and it is anti-addition, we always get a racemic mixture, car, remember this. When we say bromine CCl4, the adding molecule, the adding entities are Br plus and Br minus. So we'll try to form the racemic mixture. So it would be like something like this, CH3. Then we have carbon, this is H over here. This is bromine, carbon, bromine, CH3 and H. And since it's a racemic mixture, we have to draw the second molecule also, which is the reflection of the first one. So we have 2 molecules in this case, so we get racemic mixture. Next is addition of bromine in presence of bromine water. When we say bromine water, it is HO minus and Br plus. So obviously, since it's also an anti-addition, we'll get a racemic mixture. So in the previous molecule, just do one thing, that replace one of the bromine by OH, and you should be done. So it was a quick revision of the important reactions of alkenes. Hope you like this video. Thanks for watching. All the best.